Welcome back to the Quantum Health Connection podcast. Thank you so much for being here. I'm your host, Vanessa Baldwin, with amazing co-host Heather Crimson. And today we have a really special guest. I'm so excited to chat with her. We have Dr. Alexis Cowan with us today, who is a Princeton-trained Ph.D. whose interests and specialties lie in the intersection of circadian biology and quantum biology, metabolism, and the microbiome. And after she's completed her doctoral research in one of the top metabolism labs in the world, she started her own private practice where she works with professional athletes and highly motivated individuals looking to optimize their health and performance, as well as health coaches and professionals looking to expand their repertoire and tools in their toolkit. Thank you so much for being on the show, Dr. Cowan. We are so excited to chat with you today.
Thank you for having me. I'm excited to be here and I'm excited to chat with you guys. I'm sure we're going to have a great talk.
Oh, awesome.
Absolutely. So let us know how you got here. Like Vanessa just gave us a short and sweet overview, but like what was the pivotal moment when you realized, okay, this is not all that I need to know about. Like I need to go into this whole new realm, right? This whole quantum box, or not box, but you know what I mean, like this universe. What was that moment in your journey where you realized there's a whole lot more that you need to know about?
Yeah, so it was pretty straightforward. I was at my postdoc at UPenn last year, April 2023, and I received a DM from somebody who I actually cannot track down who they were. I've been meaning, I want to like send them flowers or something. But anyway, they sent me this podcast, which was Uncle Jack Cruz talking with Andrew Huberman and Rick Rubin on Rick Rubin's podcast, Tetragrammaton. And I listened to that episode. It was 2 parts. It was like 6 hours between the 2 parts. And I was just blown away the entire time. And on one hand, in awe at the information. On the other hand, kind of pissed off that I hadn't heard anything about any of this prior. And circadian biology had been on my radar prior to that. But for whatever reason, the way it was communicated just did not emphasize the importance and like the very foundational aspects of light and how it's influencing biology. And so that really sent me down the rabbit hole. Ever since then, I more or less have studied probably like 8 to 10 hours a day every day for like over a year and a half now, because it consumed me essentially, because I realized there was so much that I didn't know. And I feel like some individuals, like depending on their, I don't know, upbringing and nervous system regulation, they could see that as a threat to their ego. Like, oh my gosh, I've been giving this information out and it's wrong, so I'm going to stick to my guns and I'm just going to pretend I didn't hear this new information. But I'm always somebody who's like I'm always really curious. I'm always looking for things I don't know. I'm always wanting to learn new things. And so when I found this information and went down this rabbit hole, like fully embraced it. Like, first of all, the first, let's say, week after finding Jack's work and going down the rabbit hole on his podcasts and blogs, I just changed my whole life essentially overnight and
Wow.
started blocking blue light at night and staying outside all day essentially. And overnight, I essentially became like a morning lark, whereas my entire life prior to that, I had always been a night owl and wanting to stay up late and sleep in. And I always identified with that label. And then I realized very quickly, like, oh, that was literally just a product of my environment. That wasn't actually like an innate aspect of my being, that some people do identify with that. And I really think that's like an emergent property of the modern light environment. It's not like an inherent thing as humans.
So are
Prototype.
chronotypes what they used to describe that situation?
Yeah.
Or night owl and all that. So you don't like, I don't think night owls are actually a legitimate thing. The people will argue so strongly that no, it's a real thing. I'm like,
I was a night owl, quote unquote, my entire life, even as a younger child. Okay. I used to stay up and read books all night long with my flashlight. Like I was always a night owl until I got blue blockers and started seeing sunrise. So it definitely can change and definitely can shift. Last night I fell asleep at 8 o'clock. Okay. So I'm no longer
Yeah.
a night owl.
Yeah, it's really, if you have no artificial light in your environment, you're just going to get sleepy biochemically, physiologically. Melatonin starts going to be
Yep.
released. It's going to help you, go to sleep, stay asleep, get good quality sleep. And so if we're suppressing that with exogenous light, then yeah, that's going to make you into a night owl. But I don't think there's an inherent night owl chronotype that's like a subset of the population. I'm open to being wrong about that, but that's my hypothesis at this point, given my own personal experience in this realm. But anyway, so I like basically changed my life in the course of a week. Found immense stores of energy and just like also catharsis, because I had lost my mom like right before I graduated in December 2022. No, December 2021. December 2021 is when I graduated. And I had really some issues processing it because I had a lot going on at the time. I was also graduating. And so when I started aligning myself with the sun more, I also felt like a lot of stuff moving through me that
Mhm.
really just needed to get unstuck. And so it was really powerful for me on like my healing process and just the way I'm feeling in my body, my outlook, my motivation. And not only that, but there's kind of this concept, and I was just talking about it with Jack. I was on a call with him before we got on about how when you start listening to like the little whispers in your ear from the universe about this is meant for you and like following those threads, it's like the universe delivers back tenfold. It's like all of this good stuff just comes into your life. It's like propelling you in the direction that's meant for you. And that's what I experienced almost immediately, like just being connected with great people, just finding abundance in general, and just really, it just changed every aspect of my life and my business, because then I started, as I was researching this and going through all of the papers, I was then reconfiguring my coursework and my messaging on Instagram, and everything literally changed within the course of like a couple weeks.
But you had the
Yeah,
energy to do that, right? That's
Yeah, exactly.
and the other thing about the emotional processing that I find so fascinating is, well, my mentor calls this like living a high voltage life, but literally and like metaphorically and everything else spiritually, that's what can happen is you now have the energy because emotional distress, when you are too busy or distracted or whatever, it's like stuck inside of you. So it's taking energy because you're trying to contain it. But then
Yes.
it actually requires enough energy and flexibility, right, in various ways to be able to process it through because it's a lot of energy moving through and it's hard. It's taxing on us. So, anyways, that just came to mind. Sorry, Vanessa. I know you're going to say something.
no, I was just gonna say, I feel like when you're aligned, like your circadian and quantum biology are aligned, you hear those whispers so much stronger, and
Yes.
you're able to tap into that like innate wisdom of what your body needs, where you want to go, the directions you want in life, and things just downloads just come to you so much more. And I've definitely felt that shift too. So, yeah, that's just amazing for you to hear you share that. So, yeah.
Yeah, I totally agree. That's been my experience for sure. And now that I've been working with people in this area for about a year-ish, I've heard this echoed so many times as well, and just people's lives really changing radically quite quickly. And it really does give you like the resolve and the fortitude to be able to make more tough or difficult decisions in your life as well, whether it's
Yep.
needing to move to a new location or switch jobs or leave a relationship or sever friendships or whatever it is, have the difficult conversations. It's like you have so much more energy reserve available to do those things, and they don't become this life-shattering situation anymore. It's now you're actually approaching it forthrightly, and that also engages a different part of the brain neurocircuits, and that's something Jordan Peterson talks about quite a bit, where if you're
Mhm.
approaching challenge forthrightly, like intentionally, it engages the norepinephrine and dopamine system that allows you to get a reward from doing the hard thing, and then helps you to do hard things again later, in like a way that feels almost more effortless, versus if you're constantly a victim to your reality and your surroundings, then you're not engaging those pathways. You're basically just being broken down by your environment instead of pushed and like basically growing and through hormesis essentially.
Right, because
Mhm.
you're reacting, you're retreating, you're like, you're protected in a protective mode instead of an embracing mode, an opening mode, and a curiosity mode. So very different experiences, right? You mentioned moving. Is that something on your radar? Because I know there's a little bit of conflict in the community about you have to move or no, you can thrive where you're at. So I want to know what your opinion is on that. I know it's not on our list of questions, but I can't help
Oh
asking
yeah.
now.
Great
I
one.
think it's a good question. I think for people who are very ill, it makes sense to try to increase your solar yield, and also like the reliability of like the light stability. So moving more south could make sense in those cases if it's possible for somebody. For me personally, I'm mixed. So my dad's side of the family is African and some Native American, and my mom's side is all Scandinavian. So I have Viking mitochondria. So I actually do really well with cold
Mm.
and seasonality. I feel like it kind of just jives with my system. So I'm in New Jersey where we do get seasons, and we basically have no UV light for maybe like 2, 3 weeks of the year, like at the end of December into early January. But mostly, during the summer we can get up to like UV 11, so it's not too bad. And so I feel like my mitochondria are pretty well adapted to this type of environment. So I'm not like set on moving anytime too soon, though I would potentially in the future love to move more south. I think it would make me feel happier, and also in like-minded community as well. Definitely have my eye on El Salvador.
Yeah, I'd love to move too. Maybe in the future. Right now, it's a little challenging with like I'm in New York, so I'm not too far from you. And yeah, I mean, I'm embracing the cold and the darkness much more than I used to in past, right? But I definitely enjoy like those nice summers and would love to move down to a more southern climate eventually in the future. But there's other things keeping me here in the moment. So yeah, it's cool though. Yeah.
Yeah, but to thoroughly answer your question, I guess there would be a couple considerations that somebody's health status and somebody's mitochondrial haplotype, which can kind of dictate the environment that may be optimal for them. That doesn't mean that, if you have, let's say, coupled mitochondria from a more equatorial region, that you can't live somewhere more northern, but you really have to be more conscientious, I think, about the way you're living in order to thrive in an environment like that. And maybe, there's trade-offs in everything in life. So maybe it makes sense for you at a certain stage of your life to live somewhere that's not an ideal fit biochemically or mitochondrially, but then with the intention of, maybe in the future moving into a more like a more supportive environment, let's say.
Yeah. Let's talk about that since you just brought up the coupled and uncoupled mitochondria based on your haplotype and all that. Why don't you chat about that a little bit and explain that to people because they may not know that.
Yeah, sure. So there's two broad categories of mitochondrial haplotypes that basically relates to the DNA that's in your mitochondria, which you inherit strictly from your mom's side of the family. And so if you want to understand where your mitochondrial haplotype comes from, you want to think about where does your mom's family come from? Your grandma on your mom's side, your great grandma, like your maternal, just go down the lineage essentially. Or if you have like a 23andMe test or something else, you can also like use a third-party engine to look up what your haplotype is. But you can also just get a rough sense by understanding what part of the world their family comes from. And so the uncoupled haplotypes hail from more northern regions where the ground freezes, and the word uncoupled means that the flow of electrons through the electron transport chain, which is what powers energy and water production in mitochondria, that flow of electrons is uncoupled from energy production. And it's actually an advantageous or adaptive phenomenon because when you have uncoupled mitochondria, you can more easily generate heat in response to the cold. And so that's going to be adaptive in an environment where you get extreme cold during the wintertime because you want to maintain your internal body temperature at a certain level. So that's the uncoupled mitochondria. The coupled mitochondria, as the name implies, the flow of electrons is coupled to the production of energy, which means that these mitochondria are extremely efficient at making energy. They're like, that's why also if you look at the top marathon runners, you look at like Nairobi, for example, which is a very high altitude city in Kenya. So not only is it equatorial, but it's also high altitude. And so the UV index is off the charts. Like the quantum yield or solar yield there is huge. And so that means that, if somebody who has supercoupled mitochondria lives in an area that's kind of like that, their ability to harness the energy of the sun to facilitate energy production in their systems is massive. But if you take them out of that environment, they're not now getting that solar yield, that high UV index light that's going to support energy production and water production in the body, then, we can start to run into some issues. And that's where we'll often use like vitamin D as a biomarker. So like 25-hydroxy vitamin D is the storage form in the bloodstream. That's already going to take into account, if you're optimizing that to, let's say, greater than 60 nanograms per milliliter, that's going to take into account your skin tone, because the more melanin you have in your skin, which is associated with these equatorial populations, the more melanin you have in your skin, the more light from the sun is being sequestered away. Essentially, it's actually being used productively because when that light, in particular UV light, stimulates melanin, it actually stimulates the splitting of water molecules to generate free electrons, molecular hydrogen, molecular oxygen. So it's very actually productive for melanated skin to work with full spectrum, high UV index sunlight. And so this notion that melanin is simply a protective mechanism against the harms of UV light is just not true at all. It's actually harnessing that photonic energy, that very high energy photon, to do work in the system. But anyway, so if you're sequestering that light with melanin and using it productively, you're not able to actually convert that 7-dehydrocholesterol as efficiently into the pre-vitamin D, etc. And so that's why people who have darker skin need more high quality sunlight, aka high UV index sunlight, because their skin is essentially adapted to that environment. For me, I'm kind of a mix. So like I tanned really easily because I'm mixed, half and half black, half white. And so I can tan really easily in high UV index light, but I can also, deal with the cold pretty well as well. And Jack has talked about this too. It's kind of like if you're going to be mixed, actually having like the maternal side being uncoupled and having your father's side being black actually works out, because then you can kind of be very malleable to your environment versus people who have completely uncoupled mitochondria, let's say from both mom and dad, so pretty pale skin. you might struggle in a more equatorial environment unless you really work on building up your solar callus over time. It's going to take some time. So that's basically the story of coupled versus uncoupled. It has to do with where your ancestors on your mom's side hail from. It has to do with what kind of environment you will best thrive in. One other note that I'll add about the mitochondria is that the uncoupled mitochondria from the more northern regions do seem to exhibit some level of plasticity that the coupled don't. So what I mean by that is if you take somebody from, let's say, Sweden and you move them to Miami for 10 years, and if you look at their mitochondrial function at the end of that 10-year period, you can actually see that their mitochondria begin to shape shift a bit into a more coupled haplotype.
Mm.
And so there is this plasticity that kind of makes sense because as humans, we all have evolved out of like this breadbasket in Africa. So we all started out as coupled. Over time, as migration happened towards Northern Europe, we started getting more uncoupled to adapt to that colder environment. It makes sense that some of that plasticity would remain to actually like allow us to go back into that coupled environment in the future versus people who have coupled mitochondria, they're already in that native evolutionary state that never differentiated. So I just think it's interesting to
Yeah.
think about differences. I mean, oftentimes in modern society, we're supposed to downplay differences between the sexes, between the genders, between races, but I think there's a lot of interesting information to be had there. And I also feel like I'm well positioned to talk about it as like a mutt. I feel like I can talk about these things without being like, you're racist, this is bad. Like, it's important. I just think it's important information, especially when we're thinking about how to optimize our physiology, metabolism, and our biology in different environments.
Absolutely.
Yeah, absolutely. Yeah.
Well qualified in many ways, and you get to talk about yeah, but you certainly, yeah, have the foundation there. So Alexis, talk about the light and gut, because that's one of your specialties, right? You've done a lot of work in that area, and we're super curious to learn about what the essence or the essentials that you've learned about light and gut, because it's a huge, huge connection that a lot of people don't really even know about, right?
Yeah. Yeah. So I think one of the big pillars is like this gut skin axis that's kind of being fleshed out more recently. That's really activated by UV light, in particular UVB light. So we already knew that, vitamin D is an important product of UVB light. We also know that POMC or propionmelanocortin is another really important product of UV light, which we can get into. But the UVB light also activates this gut skin axis that actually helps to increase biodiversity in the gut. So the different groups of microbes that are in the gut. And increasingly, we're understanding that diversity within the gut microbiome is a sign of health. And I would say outside of biodiversity or like the diversity of different groups of bacteria, there's not a whole lot of ways that we can assess a healthy microbiome, quote unquote, because there is a lot of variability across individuals. And I think there's a lot of red flags on the internet today. I think the microbiome has become like this kind of buzzword topic where it's like, oh, like that means I need to take my probiotics and that's going to make my gut healthy. And there's just a big misunderstanding about like what it means to be healthy. So for example, Akkermansia has become a really popular bug to talk about because it controls the tight junctions within the microbiome. It lives in like the gut mucosa and it can help to stimulate those tight junctions to work better to decrease gut permeability. And so people think, oh, Akkermansia is good. That means more is better. And so I'm going to take this probiotic and whatever, and then that's going to benefit me. But the problem with that is the microbiome is a very complex ecosystem. There's a lot of interplay between different microbial groups. We don't really know what's going on there, and more doesn't necessarily mean it's better because, for example, in the associational data, we see that elevated levels of Akkermansia are associated with Parkinson's disease. And so that doesn't necessarily mean it's causal in Parkinson's disease, but I would also say that doesn't necessarily mean more is better, that we really are thinking about different ratios of bugs likely being a more important feature of the microbiome than like the total population of just one group of them. So I like to talk about that just because there's a lot of push and like marketing around the use of probiotics for enhancing the gut microbiome, and that's not one of the pillars that I think about at all. I really have three pillars for microbiome health. Number one being light, that is activating and influencing the microbiome via this gut skin axis. Then we also have exposure to nature and natural environments, which is actually exposing us to the biodiversity that we need to even give our gut a chance to seed a more diverse microbiome. And then third would be like the effect of prebiotics and postbiotics, I would say are most important. So the prebiotics being things like the fibers, the polyphenols, and also things like human milk oligosaccharides, which are found in human breast milk, whose job is really to feed bifidobacteria in the baby's gut, in the newborn's gut, And bifidobacteria are very important. It seems like this class of bacteria is one of the ones I feel more confident about saying more is likely better, just because we see in a healthy aging population, bifidobacteria levels are elevated. And then in a chronic disease state, these levels seem to be suppressed. And we also see that there's this tight link between bifidobacteria and the immune system, whereby the bifidobacteria are training the immune system to be in a more anti-inflammatory state overall, at the whole body level, also the level of the brain, as well as at the level of the gut. So bifidobacteria is pretty important. There's a lot of foods that we don't really get in modern food supplies that feed bifidobacteria, such as the polyphenols, which are these pigments in plant foods, as well as resistant starches, which were a major feature of many ancestral diets. You can kind of recapitulate that today by eating, depending on like where you are and what season it is, because I do subscribe to a more seasonal eating dynamic, but green bananas are a really good source of resistant starch. Cooked and cooled rice, cooked and cooled potatoes, plantains, things like that. They're pretty enriched in resistant starch. Beans that are cooked and cooled as well. So those are like in the prebiotic class. Within the postbiotic class, we have things like fermented foods and research out of the Sonnenberg lab, because a lot of people assume fermented foods are good because of the probiotics, but it's actually not the case. The postbiotics are most important in fermented foods. The postbiotics are what the bacteria make when they eat a prebiotic. So let's say when a certain bacteria digests fiber, it can make butyrate or acetate or propionate, one of the short chain fatty acids. Those short chain fatty acids are postbiotics. And when you eat fermented foods, it's actually the postbiotics that are shaping the changes, the positive changes to the gut microbiome, not the probiotics. And the Sonnenberg lab research basically showed that. They showed head-to-head high fiber diet versus fermented food diet, that the fermented food diet was able to increase gut biodiversity more, and that it wasn't the microbes in the fermented food that were increasing. It was the microbes that were eating the postbiotics in the fermented food that were then being supported. So those are really the three pillars in my mind, that we have light, we have biodiversity from natural environments, exposure to those environments, and then we have like the pre and postbiotics. And then if you wanted to add a fourth pillar, I would also say that like mental, emotional, and stress, like those aspects are also important for the gut. But the reason I don't include that on the foundations of the pillars, because actually all three of those pillars influence your nervous system regulation. So I don't think it's actually at the foundation. It's probably like a second order phenomenon. Because when you're getting sufficient sunlight, and this is also going to evoke the POMC story, and you're, having enough beneficial pre and postbiotics coming in to feed the right microbes, which are influencing your neurotransmitter levels, influencing your gut barrier integrity and your inflammation and neuroinflammation, and getting out into natural environments, which is, abundant with infrared light as well. Exposure to biodiversity, exposure to green spaces, wide open spaces also activate the parasympathetic nervous system,
Yes.
able to engage your peripheral vision. And so all of these pillars actually influence your ability to have a regulated nervous system and have less stress in your life. And so that's kind of my opinion on that. And that's kind of the model that I work with when I'm thinking about the microbiome.
Yeah, amazing. I'm so glad you talked about the probiotics and all that, because people automatically think that that's the first thing. Oh, I got help. I'm gonna take my probiotic. Like that's their first like inclination of how they can help it. I'm like, well, maybe let's just pause that, because I think people take things and willy-nilly and they're like really messing with things and make things more create havoc, honestly, a lot of times, because people just like, oh, well, they hear it on Instagram, like, oh, I'm just gonna go buy that, and then they just do it, and then they're like have like a disaster. And I'm like, okay, that's not really how you fix your health. You have to change your life. You have to change your light environment. You have to be outside in nature. I love that you said about like interacting with the microbes in your environment. Like that's how we actually diversify our gut microbiome, being outside instead of being indoors. So amazing. It's very interesting what you said about, the fermented foods and the resistant starches and all of that. So now, would you recommend somebody who's struggling with gut health and doing all, like say they're outside and they're doing the grounding and they're in nature and they're getting light and they're eating fermented foods, would you recommend adding some of those foods that are not seasonal necessarily, but maybe helpful to the gut microbiome? Do you ever do that? Or is it like a case by case scenario? Like say like the green bananas, the ones that you were talking like that, like they don't grow where I live, so I would never even consider those, because I very much subscribe to a seasonal diet also. So I don't eat things like that. So are there foods in the Northeast that would work in that kind of context? That's what I mean.
Yeah, I would say, potatoes grow basically everywhere, and you can easily make resistant starch potatoes by just cooking and cooling them. Actually, something like potato salad is pretty good because the fat and the vinegar also helps slow down the absorption of the starch and just basically help it to make it more resistant as well. Or like if you're making mashed potatoes, you can like mash a fat source in, and then when you cool it down, it helps to facilitate the formation of the resistant starch. Polyphenols are also something that are pretty readily accessible year round. I mean, obviously, we wouldn't have access to a ton of berries in the Northeast in the ancestral environment, but some for sure. And those berries contain a nice amount of polyphenols that directly feed the microbiome and also directly quench inflammation in the gut as well. So I think, those are things that people can leverage. With regards to one supplement that's kind of like a food, that I do actually use is like the human milk oligosaccharides, which are found that were derived from human breast milk, but now we can like basically make them in like these big bioreactors using specific strains of bacteria to ferment them. But those, we don't necessarily find them in the ancestral environment, though. I actually don't know, like some of the more ancestral practices around like breast milk consumption. I wonder if people were consuming it, actually, not just the infants, but for women who are expecting or are currently breastfeeding, like taking even just an ounce or two of your own breast milk per day is amazing. And for your husband too, or like whatever, share it with the family if you have enough, because it's really, really great for your gut.
Yeah, well,
Man,
breastfed. My mom wasn't breastfed, so this creates a problem, right? With the starting
yeah.
off at a bit of a deficit. So I've had lifelong gut issues and leaky gut and all the things, and SIBO and God knows what else. So resistant starches and all those kind of things really bother me. So I'd have to back up. So maybe what you're talking about, the human milk oligosaccharides, would be a precursor because I can't tolerate those kind of starches at all.
Yeah, so usually, whenever somebody's dealing with like really long-standing gut issues, especially if they weren't breastfed, we really know that we need to support bifidobacteria because essentially like over 90% of the gut microbiome in the infant is bifido. And if you're not breastfed, and most formula, like up until 2000, early 2000s, let's say, there were not any human milk oligosaccharides in formula. We didn't know they existed. And so that's a huge problem for people who were formula fed like before this time because we didn't even know that that was important at the time. And if you're starting out basically at a deficit with bifidobacteria, it's just going to dwindle from there. And in their absence, you're more susceptible to inflammatory diseases and asthma, allergies, things like this. So we want to gradually help to build them up. Usually I leverage an anti-inflammatory protocol first because typically lower bifido is associated with some low-grade inflammation in the gut. So of course, like the light story comes into the play there as well with the red and infrared light and the UV light, the circadian biology as well, because there's a circadian clock that's kind of linked between the gut and the brain, and we need to make sure that that's coherent between the gut and the brain in order to make sure things are moving as they should and functioning as they should. But after like let's say a 2-week gut protocol, it's also very heavy on like omega-3s, especially DHA, really, really important from not only an anti-inflammatory perspective, but DHA also plays a really important quantum biological role for harnessing the photonic energy of the sun. Dr. Crawford's work is he's a powerful researcher in this DHA space. And so after that initial period, we'll start very slowly titrating in the human milk oligosaccharides. Some people, if you just take a full dose at one time, just right off the bat, get super bloated, gassy, like uncomfortable, and that's a sign of actually gut inflammation. So I can actually use that as a test to see if somebody's gut is inflamed as well. But yeah, titrating it in very, very slowly over time tends to be tolerated much better. And also starting with polyphenols first, because like I mentioned before, polyphenols not only feed beneficial microbes, but they also directly begin to quench inflammation in the gut. So you can kind of get a 2-for-1 special by leveraging polyphenols early in that process. And then start gradually weaning onto the HMOs. I use Layer Origin's Super HMO blend. It's a blend of 5 different human milk oligosaccharides. Up until this point, like even baby formulas now only have usually 2. They'll have 2-fucosal lactose and they'll have LNNT. But there's now, we can synthesize at least 3 other ones in a commonplace now. So as a supplement form for adults and for kids, you can get this Super HMO blend from Layer Origin. But sadly, like the infant formula industry is still just a mess.
Yeah.
And it's actually something I'm really passionate about doing some work in the future, is like making a more biomimetic formula product that's not full of seed oils and corn syrup and just missing a lot of good stuff as well. So I really feel strongly that we need work in that space for sure.
Oh, we so do. That is so important. I mean, unfortunately, I was breastfed. I breastfed all my kids, but my first, he was one of the like very, either allergic to my milk or something I was eating was irritating him. And what did my pediatrician recommend? I switched him to soy formula. And I'm like, oh man, I wish I would have never done that. Like now knowing everything that I know, but you don't know what you don't know then. So I just was listening to my pediatrician, and actually he was less colicky and gassy when I switched him to that. My milk was more irritating to him.
Right.
So, but of course he needed all that, I mean, he did get some of mine. It wasn't like he got zero, but we kind of like mixed, but it was, yeah, it just stinks. We need better options for moms who are having issues, or they can, or things have, there are factors that play a role, like some women who do have trouble breastfeeding, so we do need better options. Now I'm wondering, what about colostrum then, your feel on that, like for somebody to get colostrum, say from a good local farm, that's quality. What is your thoughts there, and does that support it?
Yeah, I would say it does, not in the same way, because the human milk oligosaccharides are only found in human breast milk. They're unique
Right.
to our species, but there's going to be other like factors in colostrum that can be supportive to the gut. One actually interesting thing about breastfeeding, there was a study that came out within the past couple years that showed, depending on the time of day, so for women who pump, depending on
Mhm.
the time of day that they actually pump their breast milk, like
Right.
let's say they pump in the morning and then they feed that milk to their baby in the evening, there's actually factors in that breast milk that help to entrain the baby's circadian rhythm. And so if you're feeding them morning milk in the evening, it actually can mess with their clocks, and it can create issues with, their sleeping patterns and their fussiness and just, things that we wouldn't necessarily even consider. So just thinking about the timing of like when this was pumped versus when they're getting it, or if you're pumping at all and just like not feeding directly. But I think there's ways to make that work. But I thought it was a really interesting finding, and just something that, nobody's really talking about, that actually does play a pretty big role in the child's ability to develop, and especially like early in life especially with all the artificial lights in our environment. I think every time I hear of new parents, babies being super fussy and not sleeping and crying a lot, I'm always thinking like, what does the environment look like, what are they being exposed to, because they're really meant to sleep a lot. And so if they're
Yeah.
not able to, if they're feeling some level of distress, like, the light environment and the EMFs are going to be the first thing that I'm looking into, because those are going to be the most disruptive essentially to that system.
Well,
Oh
it makes
yeah, 1,000,000%. And I wish they would have, sorry, Heather. I wish they would have told me that when I had a colicky baby back then. I mean, nobody mentioned that to me. They said, oh, like it was all about what are you eating? That was the
Yeah.
issue, and what is he allergic to, and those kinds of things. And we had Nico Kennedy on our podcast a while back. She's amazing, and she talks about, she does research in that when it comes to like the babies and all of that. And she had mentioned that to us about that. That was the first time I heard that, about how, the melatonin is produced at certain times, and that different, that is amazing. So that's how the body, or babies, actually entrain their circadian biology, again, is through that milk intake, so that's so cool.
Yeah, also the DHA content. So we know that the DHA content of milk directly is influenced by the dietary composition of the mom's diet. So that's another thing. If like a baby's super colicky or having GI issues, I'm really curious about the mom's DHA status, because if the
Mhm.
DHA status is low and they're not getting enough through the breast milk, that's really problematic for their very rapidly developing brain, also for their immune system and like the inflammation at the level of their guts and their bodies in general. So I think that's something that can be pretty easily leveraged also through like the diet and like um prioritizing seafood and like scallops and things like
Mhm.
that. Just
Mhm.
if you want to supplement as well, you probably can get away with that. But the whole food source of animal-based omega-3s are highly superior when it comes to bioavailability. And also just you're getting it packaged in the full food matrix, which is enhancing, the overall effect of the food on your body.
Mhm. Absolutely. So, tell us about the microbiome, the bacteria making their own light, and then the connection between that and melanin's impact on gut health and all of that.
Yeah, yeah. So I mean, we need to do more research, and in my light lab in the future, hopefully, I would love to use photomultipliers. Actually, I have an engineer friend, and I was like, "Can you build me like a colonoscopy probe with a photomultiplier on it?" Because I'm just so curious. Like, I want to know. Ever since Jack really proposed it. Oh my God, my dog is like, pay attention
That's
to me.
okay.
But he was like, "Yeah, I think different microbes are making different types of light, and we need to know like, is that how they're communicating? Because we're often thinking about their production of certain chemicals influencing other microbes or the gut itself. And if it's actually the light that's doing it, we need to know that. And I wouldn't be surprised also, because a lot of the molecules that these bacteria are making are these aromatic compounds, often derived from like tryptophan, for example. And we know that those aromatic molecules absorb UV light really effectively. And so they're probably working with light in some way. But at this point, I think it's still a hypothesis that needs to be tested. I think, melanin is crucial, and we see in like some early stage gut dysfunction that you can get like these melanin granules essentially forming within the gut, and on colonoscopies, they can even be seen. Doctors usually write it off as just like an observation, but that it's not like pathologic. But Jack talks about how that's actually an early sign of like liver dysfunction and fatty liver. If that's getting backed up, then basically melanin is traveling to the gut to help um, create energy and like increase the energy yield of that environment when it's actually at the beginning of like an energetic crisis, let's say. Was that did I answer your question? Or was there more to it? I forgot.
It's about like, I think you did. I mean, that's fine. What about
I had a question about the melanin, and I wanted to know if you know this. I've heard other people in this realm say that if you live in a northern latitude and you are in the cold, right? You experience cold, that you'll better hold your melanin, or you have better circadian rhythm, you have better circadian biology, and you actually experiencing cold and you're in the cold, that your melanin will hold. Because that's true for me. Like I don't really lose my tan, which I like, it doesn't really go away over the winter. And I was trying to figure out like, why is that? Like, so I don't know if you have an answer.
I do. I do. So I think that it's the case. I'm actually doing this experiment now with my partner because we recently got a Morosco forge, so we've been plunging. And I mean, usually by this time of year, I feel like I slightly start to see my tan fade. But actually, I feel like we look more tan immediately when we get out of the plunge, which is pretty interesting.
Mm,
But the way I've conceptualized this based on Jack's work and my review of the literature is that when you get cold, you're actually increasing endogenous UV light production via the mitochondria, and that can help to stimulate melanin production deep in your body. So there's different parts of your brain and body that have melanin present. So like the substantia nigra is the dopamine producing part of the brain that's black in color, and that's because it's full of neuromelanin. But there's other parts of the brain too, like the locus coeruleus, and there's also like the inner ear, the nasal mucosa, the oral mucosa, and other parts of the body as well that have melanin. And if you're supporting the endogenous production of UV light that's stimulating melanin, then what you don't have to do is pull the melanin from the outside in. So melanin or melanocytes come from the same evolutionary or developmental origin as like the brain and the immune system, the neuroectoderm. And all of the neuroectoderm has the ability to be basically plastic and kind of move around. And
Mm.
so if you're, let's say, lacking melanin internally because it's wintertime, but you're not getting cold, and instead you're sitting inside and you're in like a stable temperature environment, now what your body has to do is pull melanin from your outside in order to support essentially the free radicals that are being produced to help sequester those away and help to facilitate tissue function.
Mm.
But if you're getting cold, now you're actually facilitating that internal support of melanin production, and now you can actually leave the skin melanation present. And so that's the way I've conceptualized it. We're kind of doing just our N of 2 experiment here this winter, but I've heard this probably 10 other times from other people, how if they get cold during the wintertime, they kind of keep their tan. And I've also heard the anecdote that, I go on a flight. I've heard this from a few people. I fly like a 10-hour flight. By the end of the flight, I am paler than I was when I got on the plane. And that I
Oh.
think is also real. It's basically your body trying to deal with a very reactive and aphysiologic environment of being in a plane for an extended period of time. The amount of ROS that generates, and the melanin can help to deal with that kind of more reactive environment and sequestering that away. And so I think it's a total real observation, and we'll be able to study it, of course, in like a lab setting, but I think it makes a lot of sense from first principles.
mhm.
Yeah, I look forward to learning more about that when you guys do study it. That's so interesting. Like it's just very interesting. And I don't even super get that cold. Like I don't even have a cold plunge really that I mean, I don't really, I mean, I do some, but I don't go crazy with it. But I think that's so interesting. So
It
yeah,
is.
thank you for sharing your experience with that. So I wanted to know about, like you mentioned how we make our own light from cold, right? That's when we make our own light. The mitochondria makes its own light. So when we get cold, the body is gonna have to make its own light, right? Does the body make UVC light in any way? Do you know anything about that?
Yeah, so I think the light that is produced at the level of mitochondria are these VUV, like very low intensity UV biophotons that are like in the upper part of the UVC range that are kind of like bordering between UVB and UVC. So it's actually really strong light. It's like stronger than what we would receive from the sun. And that's why I think it also is more efficient at eliciting the same effects internally, like with regards to melanin stimulation and other things as well. So yeah, I think that's the case from what I've read. The quantum yield of those photons, I think, is something we need to know, but the problem is we're not cephalopods. In the cephalopods, the light is actually, you can see the light show while they're swimming around, like they emit light. But as, over the course of evolution, millions of years, we've actually evolved the ability to retain that light and use it productively. And actually, the research on biophotons shows that if you have healthy individuals, they emit very little biophotons. And if you look at sick or elderly individuals, they emit much more biophotons. And that's essentially like a permeability in the same way that you don't want a hyperpermeable gut. You also don't want a permeable system to allow photons to escape because now you're losing energy to your environment essentially versus retaining it and using it productively. And so I think the biophoton research that we need to do next is to be able to basically make a very, very small scale photomultiplier, put it inside of a cell and look at the light that's being directly produced by mitochondria. Because once you get to the level of like a tissue, there's going to be melanin, there's other structures within the tissue that are absorbing those photons and not letting them escape. And so it's really hard to tell how much light the body is making by looking at like the gross level from the outside. We really need to get at the cellular level in order to, like the subcellular level, honestly, to understand the actual volume of photons that's being made, because it's probably a lot.
So interesting. It's so cool that our body makes its own light. I love it. I think it's so interesting.
Yeah. And it makes a lot of sense too that like in the summertime, let's say in a more northern latitude, we get a lot of light from our environment. And so our mitochondria, let's say, don't have to make as much. In the winter time, when it's cold and the solar yield is down, the days are shorter, our body reciprocates by increasing its internal light production to basically compensate for the lack of IR and UV coming in. Now it's making its own IR and UV to a higher extent. And that's kind of creating this balance or this input of photons into the system that's required at a fundamental level. And it's actually really interesting when you think about like infrared and UV being like basically like the manna of life for humans. Like those are the most important frequencies for human bioenergetics. Those are also the two frequencies that we like block out the absolute most. So if you look at all of the standard window glass, it's all designed to block UV light and infrared light because it's seen as energy inefficient to let infrared light in because it's basically experienced as heat. And so if you're using air conditioning, you don't want heat coming in through the windows because then your bill goes through the roof or whatever. And so we block the UV light, we block the infrared light, we think we're energy efficient. But I made a post on this on Instagram a couple weeks ago where it's like energy efficiency and technology creates an energy crisis in the human body because we're disconnected between our understanding of like UV and infrared light as essential nutrients for the human biology. Instead, we're looking at it at a very superficial level, like, oh, we want to spend less money on our electricity bill, but meanwhile we're 10xing our bill on the medical front.
Exactly.
Yeah.
So basically modern living is what's causing us to lose energy because we're not getting the right inputs. We're getting the negative inputs from non-native EMFs and lack of light and so forth. And funny thing, I don't know if this is true, but you tell me, Alexis, like I've heard that people who have a lot of light leakage, that's how mosquitoes find you and you get bit more.
I've heard that.
I've
actually have heard that. I don't know if it's true, like in a lab study, but I mean, it makes sense. I had a first principle see that.
I've heard that the insects, they can see, like they have better eyes, so they can see UV light. And I'll tell you what, I've gotten bit less over like since doing circadian biology practices and principles. Like I can say that. Like I used to be so much worse with it. So I still get bit. Like it's not like I never get bit, but it's definitely less. So I don't know. There might be something to that. But I was thinking of that same question, Heather. That's so funny when you're talking about leaking light. Like that makes me think of that. They're seeing that light like leave your body.
Yeah.
It's so interesting. Yeah.
Well,
I would be surprised.
Tropical areas with tons of mosquitoes survive. I mean, because they're getting all that light. Something has to help to protect them from all the mosquitoes. They don't have the histamine response and all the things, right? Because everything is optimized. So
that makes total sense.
So Dr. Alexis, I want to know, what do you think of people who are like, into all these like parasite cleanses and detoxes and all these kinds of things? Because do you think that these microbes that we're trying to kill off by doing these detoxes and cleanses, that some of them serve a purpose in the body, and the body's doing it for a reason, and exuding those things for a reason? Because we're supposed to live in this like kind of like symbiotic relationship with these microbes. And of course, things can get out of balance and we need to work on that. And that probably has a lot to do with people's circadian biology and their indoor living and artificial light exposure and all of that. But what do you think of that? What is your take?
Yeah, I definitely have a take on this. So I think that any approach that's solely focused on like killing a quote unquote bad organism is completely myopic. We're gonna get the emergence of certain organisms or like infections, let's say, in cases of imbalance. So in a healthy microbiome, for example, in the gut, that's why like having more diversity is better because if you compare, let's say, a low diversity gut to monocrop agriculture requires a bunch of pesticides, herbicides, etc., in order to survive because it's unnatural.
Mm.
Um, Versus a diverse microbiome is more like an old growth forest or biodynamic farming where it's like the ecosystem is all working together to create health at the level of all the organisms involved. And so whenever the microbiome becomes like low diversity, for example, that can lead to the emergence or like increased risk of certain infections. When it comes to parasites, I think the fear mongering around parasites on social media is pretty wild to me because if you're living a healthy lifestyle, you're encountering parasites. If you're walking barefoot outside, if you're eating fresh foods, these are just like basic things that you're gonna encounter parasites, but avoiding the parasites isn't the answer. The answer should be to have a resilient, robust body that can not become infected by them. So you can have parasites passing through without becoming infected. For example, we have three primary barriers to parasite infection. We have our skin barrier, we have stomach acid, and we have our immune system. And we have innate immunity as well, actually. And so if those systems are online, parasites can pass through and we're not going to get an infection. But let's say like two of those pillars are knocked out. Now we're going to be more vulnerable to those parasites getting a foothold. And that's going to be a sign of typically issues at the level of the immune system. And so oftentimes when I see things like fungal infections, for example, like fungal overgrowth, if you've got like a white film on your tongue, dandruff, coloration in your toenails, poor blood sugar control, all signs that there's issues with fungal infection, psoriasis, and rashes on the skin as well. Fungal infections almost always precede parasite infections. And I think the way I've conceptualized this is that in long-term fungal infections, mycotoxins are released that begin to weaken the immune system and also compromise the gut barrier. And so then if you encounter parasites, you're going to be more likely to allow them to get a foothold into your system. And so any anti-parasite approach that's not addressing the underlying poor blood sugar regulation and mitochondrial dysfunction, essentially, which is what drives the fungal infection to begin with, if we're not actually dealing with that fundamental issue, which largely ties back to a deficiency in UV and infrared light in the environment, disconnection from the earth, not getting enough free electrons from sunlight striking your skin, and bare feet on the earth, then we're basically just doing a patch job. Like maybe we can eliminate the infection with drugs or herbs, but then, it's likely to come back because we're not actually dealing with the problem that's at hand. And so the same thing with parasites also lies with like the fungal organisms as well, dysbiosis in general, SIBO too. Like all of these are just signs of deeper issues at hand. And if we're not simultaneously dealing with those deeper issues, we're just setting ourselves up for recurrence.
Yep. Yeah, that's usually what happens. You just keep coming back. You just keep remaining susceptible. And again, you get these infections over and over again. Okay, awesome. I'm really glad you mentioned all of that. So tell me a little bit about, or like, just let the audience know, like, why does artificial blue light and non-native EMFs negatively impact our gut health?
Yeah, so non-native EMFs are also a form of light. They're in the radio wave part of the spectrum. And so just because we can't see it doesn't mean it's not there. But moreover, if you look at the ancestral environment, even just, less than 100 years ago, we could think about this. We didn't really have much by way of non-native EMFs. Of course, the AC power grid was rolled out in like the late 1800s, early 1900s. And that AC power grid was like the first form of non-native EMFs that we really started encountering. If you want to consider like the incandescent bulb before that, I could potentially agree with you there, though I would say much less of a problem than things like our modern LED and fluorescent bulbs, which we can get into why that's the case. But the AC power grid is inherently discordant with our biology because all of biology and life runs off of a DC current, a direct current. The alternating current, the AC current, basically has these pulses, and that's what creates that flicker that you'll often see in LED or fluorescent bulbs. It's literally the pulsing of the AC current. And the reason the AC power grid was actually the one that was rolled out is because it can be scaled at a much wider range. So like you can power a whole town or a city with an AC power grid versus a DC power grid, it would need to be at a much smaller scale, and it's not as lucrative, let's say. So of course we were I'm going to assume ignorant about this at the time. I don't necessarily think there was malice involved early on, but I'm open to being wrong about that as well, because I do think at some point along the timeline between the early 1900s and now, people wised up to what the effects were on our biology and started actually leveraging it for harm. And so if we think about non-native EMFs, the most prevalent and harmful one in our environment is likely blue light, artificial blue light. So if we're thinking about our LED and fluorescent bulbs, all of our device screens, phones, computers, tablets, TVs, all use like a blue pump technology. And the LEDs and fluorescents also, if you look with a spectrophotometer, huge spike in the blue and basically no red or infrared at all because they're quote unquote energy efficient. Same with the blue pump LED screen technology. They're very, very low in infrared, basically none. And that allows them to basically not overheat as much, to last longer, and also to hijack our dopamine systems. And if you look at the patents around blue screen technologies, it's really like there's knowledge around this for a period of time showing that it can really hijack your reward system and make you addicted to using that tech. And so, we really need to be mindful and proactive about blocking these forms of blue light when we can, because they really just burn out the nervous system. They directly inhibit mitochondrial function. So whereas red and infrared light can stimulate mitochondria to work better and work more efficiently, blue light actually has the opposite effect. And in nature, we always encounter blue light. So if you think about midday sun's about 25% blue light, over 50% red and infrared light. So whenever we encounter blue light in nature, it's always balanced with an abundance of red and infrared to help mitigate the harms on mitochondria. But in the artificial indoor environments where we're blocking infrared light and UV light coming in through the windows, and then we have all of our LED lights on and we have our computer screens on, we're really flooding that environment with blue enriched light that's directly harming the mitochondria in our skin, eyes, and proximal brain regions. That has many knock-on effects, not to mention the effects on the circadian clock, because blue light is the primary stimulus to the retina and the retinohypothalamic tract to signal to the master clock in the brain, the SCN, what time of day it is. And so if you're exposed to blue light, especially at nighttime when the sun's not out, you're sending the signal to your body that it's the middle of the day. And now you're not only suppressing melatonin release, so you're going to have poor quality sleep, but you're also going to, set yourself up for poor recovery in general. Your system is never going to fully shift into that rest, recovery, parasympathetic state during sleep that's required for regeneration and tissue renewal. And, even one night of that is going to be stressful on the body, but most people are doing it for 10, 20, 30 years and not realizing what they're doing, and then get a really scary, like, life-changing diagnosis and think like, why me? I'm a victim. But really, it's like we need to evolve our awareness around these topics because it's highly actionable. There's so much that we can do to mitigate our exposure. And like, first of all, just like getting outside more is number one. And whatever activities you're going to do inside, do them outside. Typically, I record podcasts outside. It's like raining today, so I have my windows open though to get some natural light in. I'm also using this Nira lamp. You can't see it, but it's like shining on me. And the Nira bulbs are they're designed by Scott Zimmerman, but he's a big like near infrared light researcher, and they're enriched in the near infrared light part of the spectrum. Helps to add some of that back into the indoor environment. And this is also a DC lamp, so it's a DC current, not an AC. So there's no flicker, no non-native EMFs as well. So yeah, just some simple things we can do. Of course, blocking light on the screen. So you can use a program like Iris or Flux to filter out blue light and add like an amber hue to your screen during the day and a red tint at night. Same with your phone. If you have an Apple device, you can do endogenous settings, like the native settings, to put it onto like a red or amber mode. For lights, you can actually get DC converters for most of your lamps and get DC light bulbs so that you can avoid the flicker, or you can just also opt to open your windows more and get more natural light that way, or just do your work outside whenever possible. And of course, you can use things like blue blocking glasses if none of those other options are available. If you're working in an office building under artificial lights and on screens all day, and you can't put a filter on your screen, let's say, then you would want to use like a daytime blue blockers, or if it's at nighttime, or a nighttime blue blockers to block all of the blue light that's coming in. So those are just some tools that people can do. There's lots of ways to mitigate it. But I would say that if you're working an office job that like is a 9 to 5 and it's preventing you from getting the best hours of the day in the sun and is really like putting you in a toxic environment, it's definitely a position that like I would seriously think about, like, how can I make long-term plans to get out of this position, essentially.
Oh yeah,
Absolutely. Because you're just
definitely.
basically handicapped the whole time and you have no power, you can't, you're scheduling, it's just there's no control. And that's really
Yep.
dangerous. We want people to have the ability to do whatever they need to do to
Mhm.
get the nutrients they need, the frequencies they need. So we don't want to run out of time and not talk about Palm C more. And one of the questions we'll just start off with that you were talking earlier about, Vanessa, before we got on, is that does UVA light play a role there, or is it just UVB in helping us with the Palm C?
Yeah, so the research suggests that UVB is like, it's something like 50 to 100 times more efficient at stimulating POMC, and that's because UVB light is it's stronger than UVA light, so it has, um, well, if we think about POMC, the way that it's turned on, it actually works by when UVB light in particular, but it could be UV light in general, stimulates the synthesis of P53, which is this tumor suppressor gene that essentially triggers when DNA damage occurs. And that sounds like scary or bad or whatever, but the skin was evolved or was designed as a sacrificial layer that turns over really quickly. And so it's actually, it's part of the system to have this effect that then stimulates POMC that can then create this adaptive effect where we're not only, so actually to backtrack, when we make POMC from UVB light, we're making it in the skin and also in the brain via the eyes. That's being cleaved. So this POMC prohormone is cleaved into 10 different hormonal products. 3 of them are alpha, beta, and gamma melanocyte stimulating hormone, or MSH. And so it makes sense that if you're having UVB light coming down onto your skin, creating DNA damage, and then we want to basically get the adaptive response, we want to add more melanin to the skin to essentially allow our body to harness more of the photonic energy of the sun that's available. And so the alpha, beta, and gamma MSH stimulate melanocytes throughout the body and the skin and otherwise to make more melanin. And then that melanin can allow you to harness more of that photonic energy productively. In addition to that, we also have alpha, beta, and gamma endorphins that are cleavage products of POMC. And the endorphins are really, really interesting. So they're not only like the feel-good chemicals that people think about from like runner's high or whatever, but they're also just really enhancing your baseline dopamine status. So I really like to think about addiction in general, whether it's to food, social media, drugs, alcohol, pornography, whatever it is. Addiction is really stemming from a poor dopamine status, and your body is constantly seeking a hit because it needs to get the dopamine from somewhere, essentially. In nature, if you're outside in UV light or in the cold, making your own internal UV light, you're naturally stimulating the endorphins that are keeping you kind of riding at like as cruising at altitude, essentially. And you're not going to feel as compelled to reach for quick hits of things because you're already operating from a place of fullness. Versus if you're living an indoor lifestyle on screens all day, you're going to want something to quote unquote take the edge off. And that's literally your body craving sunlight, but we just basically instead reach for the quick hits of dopamine instead. And so that's part of the endorphin story as well. But in addition to that, the endorphins also modulate immune function. They also help to improve critical thinking, learning, memory consolidation, cognition in general. And so really, really powerful from a critical thinking standpoint. And it really also shows at the societal level how deficient we are in UV light because it's essentially reflected at the level of like dogma and tribalism that we see at the collective level, that really like there's an inflexibility and a lack of neuroplasticity at the end of the day, which directly also is influenced by our blue light exposure as well, because whenever we're pushed into a more sympathetic state like blue light does, that inhibits neuroplasticity, the ability to critically think, the ability to make connections between disparate ideas, to form new neural pathways that allow us to learn and like grow as an individual and grow our knowledge base as well. So there's a lot of implications to poor light environments, both getting a lot of artificial light and not getting enough natural light. We really need to be minimizing our artificial light and maximizing our natural light in order to get the adaptive responses in place that can allow us to be operating from like our potential, let's say.
Mm-hmm. Mm-hmm.
We are meant to be addicted to the sun, right? When
Yeah.
nature really intended for that. So you're meant to be outside and feel good and then want to go back to that stimulus over and over again. And I mean, I think it's the most addictive thing that I've used in my life, and I love it in every way. So I get so sad when the UVB leaves. But
Yeah.
so basically what you're saying with POMC is that UVB is going to stimulate it more strongly than UVA,
Yes.
but you still, even in the winter in New York, UVA will still stimulate it. Is that my understanding? Just in a lesser intensity?
Yeah, I would say that. I believe UVA light also goes down, like the total UV light coming in the winter goes down. You'll still
Yeah.
get some UVA through the atmosphere. But I would say also getting cold. I think we need to do these studies still, but I wouldn't be surprised at all if cold also stimulates POMC internally, especially with
Mm.
the brain, I would guess. But we can, we're gonna have to, that's a hypothesis, but we can test that.
That's
You have so much
interesting.
work to do in your lab.
I
Yeah.
know, too much
Yeah.
work.
And I've heard you also say on other podcasts about making sure that you get the skin and the calves,
Hmm.
exposed to that light, which is
Hmm.
very encouraging because because obviously UV light is not going to penetrate through clothing, right? So, um, it's very encouraging for us in like these more colder areas. I'm like, okay, at least if I wear my shorts, I'm still getting it in my calves, right? Like not necessarily
Yeah.
what I got because it's hard to be outside when it gets that cold in less clothing. But yeah, can you tell us why that is?
Yeah, yeah. Well, it's actually really interesting. So if you think about it, we're like bipedal mammals, and like as in our previous forms throughout evolution, let's say, if we're on all fours, our back is the primary thing exposed to the sun. And also, I really like to think about this in general. Like we're basically one of the only mammals that's completely hairless, that
Mm.
is also diurnal. So we're meant to be outside in the sun, and we're hairless, which basically means that evolution or nature is telling us that we need a lot of sun to thrive. Otherwise, we would have kept our hair that would block out a lot of that sun from interacting with our skin.
Yep.
And so when you're on all fours, your back is exposed. And, that would be a primary way that you could pick up UV light. But because we stood up, now on the front of our body, our abdomen became a major point of exposure. And so that's where it makes sense that the nerves under the skin of the abdomen could be big POMC producers. And then on the back side of our body, we have our calves that are now being exposed as well that wouldn't have otherwise. And now, we're able to stimulate those nerves as well to make POMC within the periphery. And so I think that's like from a teleologic perspective, it makes a lot of sense why those areas would be particularly high POMC producers. And it also makes sense why we have hair on our head because our head is completely, parallel to where the sun's coming down, it's perpendicular to the sun. And so that's what it's allowing us to basically, not only prevent too much light from getting in through the skull. I'm sure that's probably one reason we want to regulate brain function pretty tightly.
Mm.
And so if we're getting too much light coming in, that could be a problem from a mitochondrial standpoint. Maybe we're revving the engines too much. But
Mm.
I also wouldn't be surprised if hair is playing some sort of other role, like it's transmitting light maybe into the body because there is a lot of melanin in it. There's a ton of melanin in hair. I'm sure it's not doing nothing. Melanin is, expensive to make like anything else. And I'm sure it's very intentionally placed in this area that's receiving a lot of sunlight. So some more research studies that need to be done.
There's
Yeah.
basically like a receptor or a sensor or a antenna. I don't, right?
Yeah. I
Yeah.
think that's probably what's going on. Yeah.
That
So
is so
cool.
cool. So as I know we had to wrap up soon, but we want to ask a couple more questions. I wanted to ask you, can you just share with our audience why vitamin D supplementation would not be, is the same as going out in sunlight? How that's not the same. It is not comparable. Could you just share your thoughts on that a little bit?
Yeah. So if we think about the role of 25 hydroxy vitamin D in particular as a biomarker of your sun exposure, if we're basically taking a supplement, we're going to be masking what our true vitamin D level is. And so we actually won't know if we're getting enough sun for our bodies. There are a subset of people, let's say 1 to 5% of people who don't increase their 25 hydroxy vitamin D levels in a linear fashion in response to sun exposure. So there's some exceptions there with using it as a biomarker, but for most people, it can be a good biomarker, a good readout for your sun exposure habits. If we look at 125 dihydroxy vitamin D, which is the active form, there's not a one-to-one relationship between 25 and 125 hydroxy forms. The 125 hydroxy form is highly regulated. And so basically, if you just make a ton of 25 hydroxy, it doesn't mean it's going to increase 125 hydroxy directly. There's a ton of regulatory mechanisms in place that regulate how much 125 hydroxy is present in the body, because that's the bioactive form that's working on gene expression and other things as well. But the 25 hydroxy form is really this reservoir in the bloodstream that's serving as this biomarker of your sun exposure habits. And so, just like I said, at the basic level, supplementing is going to block your ability to know if you're getting enough sun for your body and your skin type, for example. But outside of that, we're also breaking the mechanisms, the feedback mechanisms that are in place if we're supplementing with vitamin D. So we know that there's a circadian aspect to vitamin D as well, because we're supposed to be making it during the daytime, of course. And so depending on what time you're dosing vitamin D supplement, that could be problematic, because it could be sending the wrong signal to your body, like if you're taking it at night, for example. Outside of that, we also know that LDL cholesterol made by the liver sent out into the circulation. It's a major transport form of like the cholesterol particles that can drop cholesterol off in tissues that need it. The skin is a major reservoir for cholesterol, and one of the major sinks for cholesterol is vitamin D synthesis. And so I know Jack has talked quite a bit about how if you supplement with vitamin D and you don't get enough sun, that's very closely linked with elevated levels of LDL cholesterol, which isn't necessarily a bad thing. I think LDL cholesterol is mostly demonized unjustly. I think it's mostly a canary in the coal mine for metabolic issues at the level of the liver, and it's not actually causing issues. And I think there's more and more research coming out on this topic as well. It's kind of blowing up the whole story about LDL cholesterol being bad, so to speak. And even if you look at like the guidelines over time, before statins rolled out, the guideline was like 200 milligrams or 200 milligrams per deciliter or less is fine. Statins rolled out, now 100 milligrams milligrams per deciliter or less is the benchmark. And even more recently, they're now trying to push it to 70 milligrams per deciliter or less as the benchmark, which is insane because if you actually, yeah, it was like in the past few months.
Wow.
And if you look at the epidemiologic data, it's really strongly states that essentially if you're in like your sixth decade or later, like 65 years or older, that elevated levels of LDL cholesterol are actually protective against all-cause mortality. So what are we actually doing by pushing cholesterol slow? It's pretty insane, especially because a lot of these statins, like most of the ones that are used, like the Lipitor and Crestor, they're pretty fat soluble, which means they're affecting lipid synthesis in the brain because they can pass that blood-brain barrier. And now that can cause things like dementia and, cognitive decline and all of that. So, and also on top of that, statins are also mitochondrial poisons that are derived from fungus. So the fact that we're using them at all is very, very sketchy. And
It makes
also,
me wonder what the agenda really is,
Right. And it's also, just completely missing the point about like, okay, why is there metabolic issues to begin with that's creating the elevated levels of lipids, and just like totally missing the forest for the trees. But yeah, so that's kind of my thoughts on vitamin D supplementation. I think it's mostly just you're missing the bigger picture if you're supplementing with vitamin D. There could be some exceptions, like people with rickets, because vitamin D does serve really important roles in calcium homeostasis and in the bone and everything in the teeth as well. So if you're somebody who has like, less than 15 nanograms per mil of vitamin D in your bloodstream, maybe you want to supplement in the short term just to get things up and into a more decent range. But with the long-term strategy of planning to get your vitamin D from the sun, then I'm totally cool with that. But for people who are like, let's say above 30 nanograms per mil, then there's no evidence in the literature that suggests that supplementing is doing anything for you, even though having levels of vitamin D over 50 or 60 nanograms per mil is associated with decreased cancer risk and autoimmune disease risk and diabetes risk. But supplementing doesn't show any benefits on those outcomes. So it's really that the vitamin D is serving as a biomarker for your sun exposure habits. And when you're out in the sun, you're getting red and infrared light stimulating mitochondria. You're getting UV light that's stimulating not only vitamin D, but POMC, the gut skin axis. We're getting the benefits of UVA light on nitric oxide production and blood flow, waste removal, and oxygen delivery to tissues. We're getting all of these effects at one time that could never be distilled down into a pill.
Never. You can't replace the sun with a pill.
Yeah.
Never. It's not possible. And there's so many other benefits that are happening, like you just said and mentioned, simultaneously. And yeah, I think people think that though, when they hear about like, oh, you should get more sun, they think, oh, that's because I need to get more vitamin D, right? And they don't even realize that they can't make vitamin D in the winter. They can only make it in spring through fall, but they think that's the only reason that they need it. And they're like, oh, well, if I don't want to go outside because I'm afraid of skin cancer or blah, blah, blah. And then I'll just take my vitamin D pill. And then we're causing more issues. And then we're not taking that cholesterol and turning it and sulfating it in to use to make vitamin D and make other hormones and do all the steroid hormones that we're making from there. So, and then we're not expanding our exclusion zone water, which is going to then, keep the lining of the arteries from getting, heart issues. Like there's so many pieces to the puzzle that we're just totally missing it. And I'm just so glad that you are a researcher in this field and that you are bringing all of this to the light and just sharing it with your perspective and, just all the knowledge and wisdom that you're sharing is just, I'm so grateful for it. And I'm really excited to know what research you're going to plan on doing in the future because I hear about this lab that you're doing. So share about that because I definitely want to know.
I want to know what you're working on right now and then what's coming in the future.
Yeah, both. Yeah.
Well, so I am working on something really interesting right now, but I'm not quite ready to share about it yet, but it's going to be very cool. And it's essentially working to increase the bioavailability or like the yield of UV light in the environment through a very, let's say, an unconventional and kind of innovative way. But you'll hear more about that soon.
Okay.
Outside of that, yeah, I'm really just focused on diving into the literature. I'm specifically looking right now into a lot of Becker's work, and really diving into that as part of my homework for this other project that I'm working on, as well as Gilbert Ling's work as well. Andrew Marino's stuff is also great. And so I'm doing a lot of reading and like just really getting clear on like my initial hypotheses that I want to test. Like even before the lab gets built out, I basically have almost all the equipment I need to start doing some just intro pilot studies here at my house. So I'm just trying to go back to like the way science used to be. It was literally just like usually men tinkering around, finding some really cool things and then like talking about it. Now it's become this whole industry of like scientism and the industrialization of science and like the pharmaceutical, medical, military industrial complex that's just hijacked science and is essentially breaking it. It's pulled us completely away from being able to do actually good, curious, and like open-hearted science, let's say. It's much more driven by profits and only certain questions can be asked. And so I'm really trying to find all the low-hanging fruit that I can, especially in the realm of like mitochondrial biology, light biology, and really starting to just do some basic studies at first to just kind of recapitulate some findings that other people have had and then starting to do some new studies. And then hopefully I hope to have like an actual brick and mortar at some point too, where I'm gonna fully privately and philanthropically fund the lab, not going through grant funding. That's like a whole trap if you want to go that
You have
way.
to maintain your sovereignty there.
Yeah, exactly. And we're gonna be Bitcoin based lab as well, speaking of sovereignty. Because I think it's the only way that it's gonna work. Otherwise, if well, between inflation and then other people being in control of what my money's value is, it's going to be problematic from a scientific perspective to have integrity and not follow where the money is taking you, which is what most scientists are forced to do essentially because, oh, well, they spend like 90% of their time writing grants for funding from agencies that have very specific objectives that they're going to fund. And so if you're interested in anything outside of that, you're kind of SOL. So I'm not trying to fall into that trap. I have very specific interests that aren't within the interests of the three-letter agencies, and so I need to go about it a different way. But yeah, that's kind of like in the, let's say, 5 to 7 year plan is having a brick and mortar. But for now, I'm just like trying to do experiments ASAP and get some results out into the community.
Well, you're pioneering like a whole new approach to which vitally needed. Like it's going to basically pave the way for a path to save humanity as far as the medical, paradigm and helping people understand what's really possible. So this is amazing, right? So you're saying you're building your own lab, or is it at Princeton, or how are you like going about it?
It's going to be my own. It's going to be its own complete thing. I'll probably end up collaborating with certain academic labs for very specific experiments, but yeah, it's not going to be grant funded. I don't want an institution like lording over me as well, like telling me what to do. I just need to be able to do what's right and what's interesting to me, and that's that. So I'm
You
going to
need
try and make it
control.
happen.
Full control. That's so good.
That's awesome. I love it. That's so great. So, Dr. Alexis, anything else you want to share with our audience or leave any, parting words of wisdom, anything else that that we didn't touch on that you wanted to touch on that you want to share, anything else like that? Let us know.
No, I think we covered a decent amount. I guess the words of wisdom part, I think I made a post yesterday about this, but it's worth saying on here is that like we just need to get back to questioning everything and stop taking information at face value from people who have a track record of having no integrity, essentially. I know it's inconvenient to have to think for yourself sometimes, especially if you're blue light toxic and like burned out and just trying to make it day by day. But really, just by reconnecting with nature and the sun, we can begin to build our fortitude that will allow us to have the energy to critically think and ask the hard questions and make challenging decisions sometimes that are ultimately going to be for our betterment. And I think we can't afford to be living the way that we're living much longer as humans. It's very unsustainable at a core level, and not from like the sustainability at the level of like the propaganda around sustainability and climate change or whatever, but like we're destroying our bodies, we're destroying the planet. We're not living in a way that's in harmony with nature, and we need to get back to it in order to actually discover our potential, because right now we're wasting it.
Mm. Well said. Really well said. Yeah, it's really sad. And I worry about the future. Like I really do. Like the way that these kids are growing up with, all of this technology and all of it. Like we did not grow up like this. And now they're up against so much more, right, than we were in the environment when I grew up. And it just, I worry about that. So the more we can spread this knowledge, make people aware, because most people, like when I bring this stuff up, they have no idea. They're not even close to aware of that, their lighting environment, or their exposure to the technology that they're looking at, or just, the Wi-Fi, the earbuds, or like anything. Like they have no idea that this is impacting their health. So the more we can spread this message and then get them to start questioning things and opening up their minds is amazing. So I just, like I said, I thank you for doing the work that you're doing, and really appreciate you. And yeah, thank you.
Make mitochondria great again.
Hey, yeah.
I love it. I love it.
Are you selling those?
Yeah. So tell people where they can find you, follow you, all that.
Yeah, so I'm most active on Instagram, though I'm gonna start cross-posting over to X because the censorship on Instagram is like insane.
Yep.
But I'm on Instagram at Dr. Alexis Jasmine, Jazmyn. Same over on Twitter or X. I try to post most days. I'm really active in stories, talking about like what I'm up to and products that I like, and just ways that people can support themselves in small and big ways. I have in my link in bio, people can buy this shirt. People can also enroll in the new course that I'm relaunching next month. So I had initially, after I graduated from Princeton, had a boot camp course, which is basically like a protocols-based course around different aspects of health. And since then, I've learned so much that I literally have to reteach the course because it's all out of date now. And so everybody who was in it the first iteration, I'm giving it to them for free because I'm like, I feel bad that all of that information isn't really relevant that much anymore. And so now we're gonna be in there. We've got about like 80 people enrolled so far, between like the old students and the new ones, and that's starting October 16th. So it'll be like weekly live lessons. We have a Telegram community, lifetime access to that, so people can find information about that in my link in bio. My website's also on there, and I'm pretty active in the DMs as well. If people have questions, they can reach out.
Wonderful. Well, thank you so much, Dr. Cowan. We're really, really glad that we got to visit with you. And like, it's just a wealth of information. Something that washed over me. Some of our listeners may need to listen to it twice because it's very dense, but so yummy. And we're so grateful for your time. We know you're super busy. So
Oh, yeah, my pleasure. This was really fun.